to halfway through the week. It's already Wednesday, and we are ready for lesson 79, factoring trinomials. Trinomials. Tri means three. Okay, so we're going to have at least three terms. Great. Don't get scared, don't get nervous. We can do this. First, we're going to take a look at trinomials with a positive lead coefficient. Before we can talk about whether the lead coefficient is positive or not, we need to make sure that we have the trinomial written in the correct form. That is, we need to find out which of the terms should be first. Each term only has one variable, and it's a for all of them, so that makes it easy. It's the highest exponent down. Very good. So it is written in the right order. 5 is first, the exponent 5. So the lead coefficient is the coefficient that comes before that first term. When we don't have a lead coefficient that's visible, when there's no number present for that first term, we understand that the lead coefficient is 1. So we're looking at a situation where we have a positive lead coefficient. In this case, it is a positive coefficient, and it is the number 1. Now, we need to identify what the largest factor is. What is the greatest common factor for all of these terms? That means we need to go back to prime factorization. So, a to the 5th is a 5 times. A times A times A times A times A. The next term, 3a to the 4th, 1 times 3, that's the prime factors of the number, and then A times A times A times A, that is 4 a's, 1 a for each exponent number. And then we have 18a cubed. That is 2 times 3 times 3. I know that 18 is 2 times 9. So 2 times 9, and I know 9 can be factored into 3 times 3. And then 3a's. A times A times A. If you still feel like you're not strong in prime factorization, if you can't look at them and do the process in your head, that's okay. You can go back to the good old factor tree or to the birthday cake or hat and simply say, what are the factors of 9? Or, I'm sorry, what are the factors of 18? 2 times 9. Is 2 prime? Yes. Is 9 prime? No. What are its prime factors? 3 times 3. They're both prime. So our prime factorization is 2 times 3 times 3. All right. Now, we're looking for the greatest term, the greatest factor, in all 3 terms. Well, this one only has the number 1. So we don't have any numbers that we can take out. Okay? But they all have a's. The greatest factor, the greatest thing I can take out of each one is however many a's are the smallest. This is 5 a's. This is 4. 4 is less than 5, so I can take out 4. Oh, but over here we only have 3. The greatest common factor will be 3 a's. I can take 3 a's out of each term. This is kind of like doing the reverse distributive property. It's almost like setting up a division problem, only we're not really dividing. It's just the terminology we think of as we do the problem. So if we factor it out, it means we take that and we pull it to the outside. So we have the a cubed to the outside, and now we're going to start a set of parentheses. Our question becomes, if we divide a to the 5th by a to the 3rd, if we take a to the 3rd out, what remains? What remains is not underlined, and it's a times a, which is a squared. We come back to our problem to find our sign, plus what remains if we take a cubed out of 3a to the fourth. We still have our 3, and we have 1a. That is 3 times a. We come back to our original problem for our sign, minus. If we take a cubed out of 18a cubed, what remains? In this case, we took all of our a's, so we have 2 times 3, which is 6, times 3, which is 18. We have just factored a trinomial. Largest factor, greatest common factor was a cubed. We write it down and start a set of parentheses. And inside, we're looking at what remains if we divide each term by the piece that we took out by that greatest common factor. The important thing that we understand is we're thinking in our head it's like division, but it's not really division. This a cubed doesn't go away. We're undoing the distributive property. If we wanted to check our work, we would use the distributive property to make sure we got back where we started, and we would. Adding exponents is a to the fifth, plus a cubed times 3a, that would be 3a to the fourth, 3a to the fourth, minus a cubed times 18, 18a cubed. So we're simply undoing the distributive property. Okay, what if we have a positive lead coefficient, but it's greater than 1? That's going to change things a little. Let's go back and make sure. All 3 terms in the trinomial are an m, different exponential numbers, different exponents, so we want descending order, 4, 3, 2. Perfect. Okay, so we go back to prime factorization. The prime factorization of 2 is 1 times 2, and m to the fourth is 4 m's. The prime factorization of 16m cubed. 16, that's 4 times 4, neither are prime. 4 is 2 times 2, they're both prime. Oh, and 2 times 2, they're both prime. Now we're done. So I have 2 times 2 times 2 times 2, and 3 m's. M times m times m. Starting to run out of room on my board. 30, we need the prime factorization. That would be, sorry, 30, the prime factorization would be 3 times 10. 3 is prime, 10 is not. That's 2 times 5, and those are both prime. So we have 2 times 3 times 5, and m squared is 2 m's, m times n. Okay. The letters are the easiest part. The least number of m's is 2. I'm taking 2 m's out of all of these. This time I need to look at my numbers. Oh, I have a 2 here. I have 1, 2 here. And I have 1, 2 here. I don't have any other 2's or any other numbers. The 1 really doesn't affect anything because anything times 1 is itself. I don't really have any other numbers to deal with here. So the greatest factor I can take out is 2m squared. That's 2 times m times m. I'm doing the reverse distributive property. Now I'm going to start a set of parentheses. What remains is the stuff that I didn't underline. M times m is m squared. Look up for the sign. Minus. 2 times 2 is 4, times 2 is 8m. Look up for the sign. Plus. 3 times 5 is 15. I'm done with the problem. I finalized my parentheses. If I want to double check, I can go back through with the distributive property. 2m squared times m squared is 2m to the fourth, and so on. All right, what if we have a negative lead coefficient? If we have a negative lead coefficient, we want to get rid of that. We want what we leave inside the parentheses to be positive. So if the lead coefficient's negative, we're definitely taking out a negative 1. Because we want, when we do our parentheses, what remains inside to start with a positive number. Okay, great. Back to prime factorization. This would be negative 1 times 3d's. This would be negative 1 times a negative 7. I want to take out that negative 1, so I need the negative 1 present. So what times negative 1 is 7? Negative 7 times 2d's. And this would be, interesting. This would be I'm sorry, I'm just thinking to myself, to make this less confusing, I might just want to say, yeah, I guess I want to leave it that way. I'll leave it that way. So I dealt with this as a positive 7. So I'm going to look at this as being, I'll look at this as being a positive 6. So if I'm going to factor out a negative 1, then if I start with 6, if I say negative 1 times a positive 6, so I have the negative 1, and then 6 would be 2 times 3. So I have negative 1 times 2 times 3. Sorry, that would have had to have been negative, so one of these needs to be negative. And then there's 1d. The negative makes it a little bit trickier because you have to really think through your signs. Okay. So we take out a negative 1. We know that for sure. That's the whole reason we played around with these silly negative numbers. And how many d's? Only 1. So 1d comes out of each. If we factor out a negative 1d, we start our parentheses. What remains is not underlined. So what remains is a d squared, d times d, plus a negative 7d. Minus a negative 6, sorry, there's no d, plus a negative 6. Okay, negative 1 times d is a negative d times d squared plus a negative, that's really minus a 7d, plus a negative, minus a negative, that's really plus 6. So we have negative d times the quantity d squared minus 7d plus 6. Gets a little bit trickier. Okay, next problem. They all have the same variable, it's all y, exponents are in descending order. Uh-oh. Alright. I'm going to try doing this one without showing you the prime factorization of them all. Because I want us to try moving beyond always finding the prime factor and just trying to think, what is the biggest thing I can take out? They're all divisible by 5. Oh wait, and this is a negative. So I'm going to take a negative 5 for sure out of each one. And they all have 1 y. So I can take out a negative 5y. If I take out a negative 5y, if I want to think through the process of saying, it's like factoring out is like division. I'm dividing this and seeing what the remainder is. if I divide negative 5y cubed by a negative 5y, the 5's cancel, and 3 minus 1 is y squared. If I divide a negative 25y squared by a negative 5y, negative 5 goes into negative 25 5 times. Opposite signs, or same sign with division gives you a positive sign. Y squared divided by y is 2 minus 1. You subtract the exponents and get 1. Negative 20y. If you think of negative 20y divided by a negative 5y. Negative divided by negative is positive, so it's a positive term now. 20 divided by 5 is 4. Y divided by y is 1. 4 times 1 is 4. So we saved a whole lot of space. We did a whole lot less work. If it's hard for you to come up with what this factor is, it's okay. Do the prime factorization. That's great. It's more important that you get the right answer than that you save the space. This will hopefully come in time as you keep looking at the numbers and working with them. A new one. Uh-oh. I know, Ronnie. Ronnie's been wondering, is it going to get harder? Here's where the harder part comes in, but it's really still not so bad. The only thing that's changed is we now have two variables. To find the degree, to make sure we have them in the right order, we add the exponents. So 3 plus 1 is 4. That's 4. So far, that's the largest. 2 plus 1 is 3. That's still a higher degree. 1 plus 1 is 2. The highest degree is this one. So we have them set up in the right order. Our lead coefficient is 3. It's positive. We have an A in every term, and we have a B in every term. Again, you can do this with prime factorization, or you can just look at it and start thinking it through. If I look at the 3, the 12, and the 15, they're all divisible by 3. I'm going to take out a 3. I have an A cubed, an A squared, and an A. The biggest A term I can take out, A factor I can take out is simply A. And they all have a B. So the biggest B factor would be B. Now, I think through it as if it's division, because I'm pulling this out of the term, so I'm taking it out, I'm bringing it away, I'm dividing it into two factors. This times something over here gives me this. Okay, well, 3 divided by 3 is 1. A cubed minus 1, because we're dividing by the A, is A squared. And B over B becomes 1. Anything over itself is 1. If I look at this as a negative 12, I have a negative divided by a positive. That's negative. 12 divided by 3 is 4. A squared divided by A, subtract the exponents, 2 minus 1 is 1. That's A. B divided by B is simply 1. Negative 15AB. Negative divided by positive is negative. 15 divided by 3 is 5. A divided by A is 1. B divided by B is 1. 5 times 1 times 1, that simply gives you 5. And you're done. One last one. Make sure the terms are written in order by degree. You do that by adding the exponents of the variables. 3 plus 1 is 4. 1 plus 1 is 2. 2 plus 1 is 3. Ah, we've got an issue. The highest degree term is first, but these two are out of order. It has to be descending order. So this should be 6x cubed y minus 50x squared y minus 36xy. Why did I do that again? They have to be in order by degree. To find the degree, you take the exponents for just the variables and add them. 3 plus 1 is 4. 1 plus 1 is 2. 2 plus 1 is 3. So we need the 4th degree, followed by the 3rd degree, followed by the 2nd degree. And now we're ready to go back to work. Uh-oh, factoring looks like it might be a little bit more tricky with this one, but we can overcome. Mr. Dixon would tell you to adapt and overcome, and you can adapt and overcome for this as well. Well, they're all even, so I can definitely divide them all by 2. If I divide by 2, I have a 3 and 25. 25 is not divisible by 3. Yes. 2 is the best I can do, so I'm going to factor out a 2. They all have an x, but this one's only x to the first, so the most x I can take out is x to the first, and they all only have y to the first, so I can take that out. I begin my parentheses. I'm factoring out 2xy. 6 divided by 2 is 3. X cubed divided by x, 3 minus 1 is 2. Y divided by y becomes 1. Negative 50 x squared y. Negative divided by positive is negative. 50 divided by 2 is 25. X squared divided by x, 2 minus 1 is x to the first. Y divided by y is 1. Last term. Negative divided by positive is negative. 36 divided by 2 is 18. X divided by x is 1. Y divided by y is 1. We don't need to write those because 1 times anything is itself. And the problem is solved. And we're done. Good luck. Hope you have a good rest of your day. Work hard to get through these, and I'll see you on Monday. Bye!